Hello, class. Welcome to our brand new semester. I'm thrilled to have you all here today. My name is Vino Usa, but you can call me Dr. Usa. Today, we are diving into something truly exciting. Our very first lesson is all about unlocking the power of Wolfram language through its implementation in Mathematica. Imagine gaining a computational superpower that lets you explore a universe of possibilities. That's exactly what we're going to embark on in this class. However, the purpose of this very first lecture is to introduce you to the language. So I'll do my best to guide you carefully so that you understand the fundamental of this language. So grab your laptops, open up Mathematica, and let's get this adventure started. See, traditional programming languages such as C++, Java, Python, and JavaScript are excellent for instructing computers in a step-by-step manner. However, the Wolfram language takes it a step further. It allows you to operate at a much higher conceptual level, making it easier to deal with abstract mathematical concepts, which is crucial for a subject like real analysis. Well, you might wonder, why can't I just use plain English to communicate with the computer? Well, while Wolfram Alpha allows that to some extent, the Wolfram language through Mathematica enables you to express more complex ideas and computations far beyond simple queries. Think of the Wolfram language as an optimized tool for turning mathematical theories and ideas into tangible results. Whether you are interested in visualization, complex calculations, or interactive models, this language is your gateway. So the first thing you want to do to get started with Mathematica is to type www.wolframcloud.com in your browser. So you should get a page like this page, and here, the sign in. Use your Bridgewater credential to sign in. It'll take you to a place like that, and then when you get here, you can click on New Notebook, and then this will provide you with a notebook. This is how you get a notebook in Mathematica. So when you open a new notebook, you will notice a horizontal cursor blinking on the screen. This is Mathematica's way of telling you, hey, pad, I'm ready for your commands. Now, I like my the background of my notebook to be black. So you'll often see that when I'm instructing this class, that the background is black. That's just a preference. Okay, so let's start with something very simple. Let's say 10. Now, once we type 10, to enter 10, or maybe let's say 10 factorial. Okay, and so to enter 10 factorial, you just type it into your notebook. Now to evaluate this command, you can press Shift and Enter, but you can also press Enter on your calculator pad. That's another alternative method. Press key Enter on the numeric keypad. So, boom. Mathematica swiftly performs the calculation and returns the result, which in this case is in front of you. After the command has been evaluated, you can use your mouse or arrow keys to place the cursor below the result. Okay, and this indicates that Mathematica is ready for your next command. Click it right here. Now that you've got the basics done, let's recreate some examples that are crucial for learning Mathematica. Now, let us start with some basic operations. So, for example, how do we add two numbers? Let's take, for example, 2 plus 2. So I'll click here, and I'll just type 2 plus 2 on my calculator pad. And you can either click Shift Enter on your keyboard, or you can click Enter on your calculator pad. I will use the calculator pad here, and then what comes out is 4. What if we want to add something different, like 1, 2, 3, 4, 5, 6, plus 5, 6, 7, 8, 9, 2, 3, and then let's click it. Let's again push the enter button on the calculator pad, and then you can check with another calculator whether this is accurate or not. We can also multiply numbers. So 232 times 7 in 897, and so we get this. So as you can see, Mathematica can act like a calculator, right? So we can add, we can subtract, we can multiply, and we can divide. Now, if you would like to turn this into a numerical expression, you use n, and then you put 8 over 9 inside 2 square brackets. So the thing in Mathematica is that every built-in function that has an argument, for those arguments, the arguments are to be inserted in between square brackets. And this is what we get. What if you want to have, I don't know, 10 digits after the decimal? What if you want 100 digits after the decimal? What if you want 1,000 digits? Right? You see? So it's a very powerful calculator. Let's try something else. Let's suppose that I want to find the digit of pi, and I want to enumerate all of them up to 200 digits after the decimal. As you can see, it does it pretty quickly. To count it. See? We can also raise number to powers, right? 3 power 4 should be 81. 9 power 2 let's say the cubic root of 7. That we turn this, and then we can reduce this, approximate this, let's say to 20 digits. So every time when you write a command in Mathematica and you want to execute the command, you either push Shift Enter, or you push the Enter button on your calculator pad. Moving on, let us explore how to work with variables in Mathematica. We'll start by assigning the value 5 to a variable named, let's say, A. Now, how do you do that? on your Mathematica notebook, I'll type A equals 5. Simply type A is equal to 5 and you press Shift and Enter. You'll see that Mathematica returns the value 5, confirming that the assignment has been made. Now that we have a variable, let's use it in a calculation. We'll compute, let's say, 3a plus 1, where a is already at this point defined as 5. So you come here and you type, let's say, 3a plus 1, Shift Enter, and that returns, as you expect, 16, right, which is the result of the calculation. Now, sometimes you may want to clear a variable's definition. How do you do that? To do this, you need a command or a function called clear. Now, in Mathematica, all functions start with capital letter. So I'll use here capital C, L, A, R, open square bracket. In Mathematica, will often close it for you right away, and then I put A. Right. So when I type clear A and press Shift Enter, this will make A undefined, allowing you to use it for different calculations later on. Next, let's explain an algebraic expression. So, for instance, I'm interested in the expression a plus 5 times a plus 9. A plus 5 times a plus 9. Now, how do I explain this calculation? I will insert this expression inside a function called expand, as shown on the screen. Then again, you press Shift Enter, or you press Enter on your numerics pad. Okay, in Mathematica, return 45 plus 14a plus a squared. And you can check whether this is actually accurate or not by hand. Next, let's solve an equation. And to this end, I'm interested in the equation 2x, let's say, minus 7 is equal to 0. 2x minus 7 is equal to 0. How would we solve such an equation? Let's see. Type capital S, lowercase OLVE, open bracket. I type here 2x minus 7, but here I'll use double equal 0, comma x. And then we press Shift Enter. Note the use of the two equal signs here. And the reason why this is the case will be discussed later, right? So we have to distinguish between when we are using an equal sign for an assignment, right? So basically, when you write just one equal sign for assigning a value to a variable, that value gets stored in the variable, and the variable here serves as a placeholder for the value. And as long as that assignment is made, Mathematica will always understand your variable as holding that value. And when you move on, and let's say you want to perhaps even, let's say, reuse that variable for another purpose, you will need to clear the variable so that Mathematica can remove that value from the association made between that value and the variable. And however, when you want to solve an equation, the equality that's used here is not just one equal sign, but is two equal signs. In any case, when you click Shift and Enter, you can see here that Mathematica returns 7.5, which is in fact the right answer. Now let's suppose that what you are interested in what you are interested in is a numerical approximation for the solution of the equation 2x minus 7 is equal to 0. How do you do that? So instead of using solve, I use capital N, capital S, OLV is numerical solve. 2x minus 7 double equals 0. And then x, and then you click shift and enter, and you get that x is equal to 3.5. To show you the power of Mathematica, let us solve the general quadratic equation. What is the general quadratic equation? So let's say we have here solve, and then I'll put here ax squared plus bx plus c is equal to 0, comma x. And so and then you click shift and enter, and then you can see that what you get is negative b plus or minus square root of b squared minus 4ac over 2a. As expected, here is the discriminants. In fact, we can play the same game by solving, let's say, a cubic equation. So ax space, make sure you put a space in between two variables. Otherwise, if you have two variables stuck together like this, for example, ax, Mathematica will just see this as just one variable. It sees that one words, because words can also be used to store variables. So to denote a times x, we'll put a space x cube plus b, cube, plus b space x squared plus c x, let's say, plus little d is equal to 0, comma x. And so you get these three solutions right here, which is the analog for the quadratic equation for cubics. And then let's see if we can keep going with okay, instead let's use let's say a specific cubic. Let's say 3x cubed plus 2x squared plus x plus 1 is equal to 0, comma x. And so in this case here, you can see that the solutions are complicated enough that the best thing Mathematica is doing here is providing you some more sophisticated way of understanding what the solutions are. And as you can see, if you read carefully, you can see that there's some complex numbers here. And since this is not very discernible for me, maybe let's use, in fact, a numerical approximation of those solutions. So I'll use instead the nsolve command, and then you get some specific equations. Yeah. And so one can say, well, can we verify indeed that we do have two complex solutions and then one real solution? How would you do this? Well, you can do this by attempting to plot this equation here. And so you may ask, how can I plot not this equation, this function? Okay, so to plot the function, you use plot, open square bracket, and then I will simply just copy and paste the equation here. And then, so I need to give the domain on which Mathematica will plot the function. So maybe I want x to go from -1 to 1. And then you click shift and enter. And then you get this curve. And as you can see, this curve only crosses the x-axis at one point. And then if you put your cursor around it, you'll see that it's approximated to be about -0.792, right? Which is sort of very close to the answer that we got here. And this is the only spot where the curve crosses the x-axis. It only has one real solutions, and the other solutions are complex solutions which you cannot see on this Cartesian plane. They say if you teach a person how to fish, then you feed them for life. So let me show you a really important resource that has been crucial for me personally. The best way I know how to learn is to try. And so for me, the help button has been very, very useful. In which sense? So suppose I'm interested in a particular concept, right? And I go to help and then Wolfram documentation. And then when you get here, you have all of these themes which are presenting themselves, to you. Core language structure. And let's say maybe what I'm interested in is, let's say, variables and functions. And what you have here is a document. This is actually a Mathematica notebook also. And let's say if I click here, right, and then it takes me to this page, sets equal, where they are very, very precise and useful information. First, on the abstract level, those symbols are explained in detail, and then you can see also here some examples, right? And so for me, the best way to learn something is to try examples. So I'll often go to the help menu, look up some example, copy the example, paste them in my Mathematica notebook, and then try. And then you can see also that for each topic in which you are interested, there is a scope. There are generalization and extensions. So if you want to learn on top of what you're build on top of what you're learning, some applications. I found the applications to be very, very useful. They're a great way to learn, and very often this can get very quickly advanced. And if you're not an advanced user of Mathematica, which I will assume since you're taking this course, I would say, pace yourself and don't try to just dive in too quickly. Definitely look at the simpler example, copy and paste them in your own notebook, and go from there. Use your own imagination and your own interest to try to see the extent to which you can use those examples that are presented to you as a template for your own personal exploration.